Hi John, I'm going to go over this iris exercise for you. Before we start, I want to talk about this iris dataset. It's a famous machine learning dataset used in education and testing of algorithms. So when you have a machine learning problem in real life, uh, you should first get an idea about the application domain. What is the data look like, or where does it come from? So understand the problem domain. Uh, in this case, this data is about three types of iris flowers, Setosa virginica and versicolor. Uh, and the goal is to differentiate between these three types of flowers based on some flower measurements. So it's a classification problem, a very typical classification problem. Uh, the measurements specifically come from the leaves of the flowers, or whatever these are called, sepal length and width, petal length and width. So there are four measurements. They are real numbers. Now we are moving to the abstract side. So we have numerical variables, lengths in centimeters, and we have three classes: Setosa, versicolor, and virginica. And in this database, we have in total 150 samples, 50 samples of each class. So 4 features, 3 classes, 150 training samples. Actually, we're going to use part of it for training. So this is a simple description of the problem. In real life, when you are given the task of designing a machine learning system, you first try to understand the problem, what the client or the customer or whoever you are working with really wants to accomplish. You have to understand that. Then convert it to a typical machine learning problem where you have either classes or a regression problem where you have a target variable and you have to determine the available features. Do you want to use the lengths of the petals and sepals? Do you want to use color, and how are you gonna measure the color? Is it feasible? Do you have cameras on the field, etc.? You have to think about a lot of problems, a lot of the details of collecting the data, cleaning up the data, and how can you formulate this into a machine learning problem. That's part of the real life application of machine learning. Once you have your data, the next step usually is to get a feel for your problem and your data. Here is a useful diagram for this purpose. This is called a scatter plot. What you see here is plots of all the available features against each other. So, for example, this first one is sepal width on the x-axis and sepal length on the y-axis. And you see the three classes scattered. All of your 150 samples are here, colored by their class, and you can see the distribution. And similarly, this is sepal length on the y-axis and petal length on the x-axis. By looking at these distributions, you get an idea about how easily separable the classes are and what features help you in what way. For example, you can see that the red class, it is Setosa, it is much easier to separate from the others, whereas versicolor and virginica appears to be much harder to distinguish. So in all of the graphs, this is pretty much the same. On top of that, you can see what features can help you in what way. So you can see that sepal width in combination with sepal length doesn't help you much in separating these two classes, whereas sepal length with petal width seems to be working a little better. And you can check other combinations if that is, for example, let's say you narrowed your focus down to separating these two classes. So this is no good. This is still not very clear. We also like to have a linear separation sometimes. So this could be useful. What we observe is the petal width, so it's on the x-axis here and it's on the y-axis here. Petal width by itself looks like a very strong feature to separate versicolor and virginica. Here you can see that blue-green separated nicely, blue-green, blue-green, and here on the y-axis also. So petal width alone is a strong feature in distinguishing between versicolor and virginica. So these are things that you get from scatter plots and more generally what we call exploratory data analysis. You explore your data, visualize your data features, and get a feel for it. From here you can get an idea about should you use a linear classifier or do you have to use a non-linear classifier, etc., etc. Do you need to extract more features? Do you need to use some combination of these features like the ratio or something, etc.? These are all things that you better do before starting a real life problem.